Okay, hello, welcome back to my class. Today we're going to talk about quadratic function. So when it comes to quadratic function, we know that, hey, this is going to look like a parabola. That's the graph of a quadratic function, the standard one. But there's a multiple form of quadratic function, such as the standard form of a quadratic function. It's going to look like fx equals ax squared plus bx plus c. And then you also have a transformation form, or we call it vertex form. So for this form, the function is going to look like fx equals x minus h squared plus k, where our h and the k is the vertex of the function. So why do we call the second one is the transformation form? Because with this function, they give you so many the information of the graph. What does the graph look like? I know that this is going to be a quadratic function. And then, since minus h, that means the graph is going to shift to the left h unit. And then you times a after you shift it to the left. You times a. So that means, let's say a is someone greater than 1. So that means your function is going to stretch vertically, look like this one. And then after you times a, you add k. So that means the function is going to move up like this one. So that gives you the graph. So that's why we call it transformation form of the function. Okay, so if you were just given a standard form, how do you find the vertex? Well, if you're given a function fx equals to ax squared plus bx plus c, the vertex is going to equals to h equals negative b over 2a, and then k, the y-coordinate of the vertex, equals to, you substitute h, the x-coordinate of the vertex, into the function and find out about that. So in this case, it's going to negative 2b minus negative b over 2a. So let me have an example. Let's find the vertex of fx equals to 2x squared minus 6x plus 7. And then how do you find that? Well, we know that the x-coordinate of the vertex is equals to negative b over 2a. So this is a standard form. In this standard form, we got a equals to 2, b equals to negative 6, and c equals to 7. And we can substitute this into our formula to find the vertex x-coordinate, which is negative b, negative 6. So that means negative 6, 2 times 2. So that gives you positive. Simplify it, I have 3 half. Okay, but that's just the x-coordinate. We still need to find the y-coordinate, k, which means I need to substitute 3 half into the function. So I have a 2 times 3 half squared minus 6 times 3 half plus 7. Okay, so don't panic when you see a fraction, because fraction is really easy to calculate. You don't even need a calculator, because we know that square means you multiply itself, which is 3 half times 3 half, over 6 and 2 cancel out. You got 3. 3 times 3 gives you 9 plus 7. And then this gives you 9 half minus 2, right? So easy. And then you find the common denominator, which is 4 half. So that gives you 5 half. So that means the vertex of this polynomial or quadratic function is going to be 3 half and 5 half. So now what if I want to, I'm giving you a function fx equals to 2x squared minus 12x plus 14. How do you convert these into a vertex form? Well, in order to do that, we're going to use a method called completing square. So you might already learn that in high school. If you don't remember, I'm going to remind you a little bit. A plus b squared is equal to a squared plus 2ab plus b squared. We're going to use that, but we're going to use the reverse way, the way that you're not familiar with, which means a squared plus 2ab plus b squared equals a plus b squared. That's the foundation. Oops, sorry, let me write this back. Of completing square. Oh, minus. Okay, so we're starting by factoring the leading coefficient from the quadratic and the linear term. So when we factoring this out, we have fx equals to 2 times x squared minus 6x plus 14. Okay, so now how do I complete square? Because I want to, what does vertex form look like? A vertex form is look like a times x plus h squared minus k. So that means we need to write something as x plus something square, which is here. We need these to be a times something to be square. So now this is what? Negative 6x, which is our 2ab. So that means I can write negative 6 as 2 times negative 3 times x, right? 2 is the second term. So that means our b is what? It's negative 3. So in order to complete the square, that means this part inside the parentheses, we need to add a b square. Our b is negative 3. So that means inside the parentheses, I need negative 3 squared. However, if you add something into the parentheses, it will change the function, right? So that means after we add it, we need to subtract them back because we want to balance the function. If you add the same number and subtract the same number, this part is going to be 0. That means you didn't change the balance of the function. The function remained the same. We'll just do some manipulation. All right. So the first 3 part, I got, hey, we can use the complete square. So that means this is equal to x minus 3 squared. And then I have a negative 9 plus 14. And now we simplify it. We need to distribute the 2 inside. So I have a negative 18 plus 14, which gives you 2x minus 3 squared, and then minus 4. So that's complete square. So basically, you need to add what? Let me use a blue one. You need to add a number in order to construct this perfect square function. So this number is going to be what? Well, it's going to be half of negative 6 and then square. If you notice, it's going to be half of that. Okay, so I know that this is very confused. It's very, very common for people do the complete square. So let's do another example. I have fx equals to, okay, 3x squared plus 6x plus 7. That's 6. Okay, first step, you want to factor in out the linear term and the quadratic term. So I factor the 3 out. I have x squared plus 2x, and then add 7. Again, in order to construct the perfect square, which is a squared plus 2ab plus b squared equals to a plus b squared, what do I need? I already have 2ab in here. I still need b squared, which means half of 2 and then square, because half of 2 is going to give you the b, but I need a square. So that means in here, I need to add half of 2. Also, I need to subtract them back because I need to balance out the function. Let's use different layer of parentheses. Plus 7. Now we can simplify. I have x squared plus 2x plus 1 minus 1 at 7. So the first 3 terms. This gives me the perfect square that I want. This is equals to x plus 1 squared and minus 1. Now let's simplify it. When we simplify, I have 3x plus 1 squared minus 3 plus 7. If we continue to simplify, I have x plus 1 squared minus 4. Now this is the vertex form. So what's the vertex? Well, the vertex is going to be h. Remember, the vertex form is a times x minus h squared plus k. So that means h is going to be -1 because you have to minus h. So that means it has to be x minus -1. That gives you a positive 1. So the vertex is going to be -1 and -4. So when it comes to a short-run behavior of a quadratic function, as we discussed in the last video, we need to think about the intercept. We have a horizontal intercept and vertical intercept, which is x and y intercept. Okay, in a quadratic function, you will see a function look like this one, sometimes look like this one, sometimes look like this one. That means in this case, they will all have at least one vertical intercept, right? That would be the vertical intercept. This would be the vertical intercept. So what about the second one? I didn't see a vertical intercept. Well, that is because you didn't draw the function big enough. If I extended the function, like I extend them, you will eventually have a vertical intercept somewhere. So that's the vertical intercept. So now what about the horizontal intercept? For horizontal intercept, the first graph going to give you 2. The second graph give you 1. And the last graph, you will have 0 horizontal intercept. 2x intercept, 1x intercept, and then 0x intercept. But they all have 1 y intercept. So now, example, I want you to find the x and y intercept for this function. Okay, y intercept, easy, which is our vertical intercept. Is when x equals to 0. I substitute the function, x equals to 0 into the function. I have 3 times 0, 0, 0 plus 2. So your y-intercept is be 0 and 2. So now horizontal intercept. Is when y equals to 0. So that means I need to set the function equals to 0. So how do I solve that? There's 2 ways to do it. Either you can use a AC method or quadratic formula. So what is quadratic formula? Quadratic formula is x is going to equal to, anyone remember? Negative b plus or minus b squared minus 4ac over 2a. So in our example, a equals to what? A equals to 3, b equals to 5, and c equals to 2. So that means when you try to solve that using quadratic formula, we just need to substitute a, b, c. Into the function. I have a negative 5 plus or minus 9 over 10. So I will have x equals to negative 5 plus or minus 3 over 10. So that gives you 2x-intercept, right? Either x equals to negative 5 plus 3 over 10, or x equals to negative 5 minus 3 over 10. So that gives you 2 results because we have a plus and minus. If the plus 3, I have negative 2 over 10, which is negative 1/5. The other one is negative 8 over 10, which is negative 4/5. So that means you were going to have 2 horizontal intercepts. One is negative 1/5, 0, and negative 4/5, 0. Okay. Let's take a look at some application problem for quadratic function. All right, a backyard farmer wants to enclose a rectangle space for the new garden, and she purchased 80 feet of a wire fence to enclose 3 sides, and will put 4th side against the backyard fence. Find the formula for the area enclosed by the fence if the side of the fence, perpendicular existing fence, have the length of L. All right. How do you do this one? Well, let's take a look. So the fence is going to look like this one because this part is the wall. We don't need to fence that up. For the fence, we have the width and the length. And I know that the total length of the wire fence is 80 feet. So that means you're going to have 2 width and 1 length. So 2 width plus 1 length, the total length is going to be 80 feet. And then what if I ask you, based on this scenario, I want you to find the maximum of the fence area. So to find the maximum, I have y equals to what? The area of a rectangle is equal to the width times the length. And then width, I know that they have this relationship. 2w plus L equals to 80. So that means L equals to 80 minus 2w. So if I substitute L equals to 80 minus 2w, I will have a function of the width. All right, let's try to substitute and see what happens. So I have a w, substitute the L with 80 minus 2w. Now let's simplify. I have 18w minus 2w squared. So that gives you a quadratic function with a variable w. Okay, with this variable, why do I need this? Because one thing about quadratic function, how can this help you? Well, when it comes to quadratic function, we know that they will have a maximum or minimum. So what does this quadratic function look like? Now let's take a look at the leading term. The leading term is negative 2w. So that means the function is going to look like this upside down. So that means it's going to have a maximum. Since this is a function of the area, right? Let me use A so that you know that, hey, this is the area of the width. So if I can find out the maximum, that means I can find out if I can find the vertex, that means I can find the maximum. So how do I find the vertex? Remember the vertex formula? H equals negative b over 2a. In this case, b, the linear coefficient, 80. A is the quadratic term, which is negative 2. So I have a 40. So that means when the width equals to 40 feet, we will reach our maximum. The area maximum equals to, we substitute 40 into the function. I have 18 times 14 minus 2 times 14 squared, which is equal to 13,200 minus 1,600 times 13,200. Oh, sorry, I calculated something wrong. You may catch me that. Here is equals to 20. The width is, because 18 divided by 4 is equals to 20. So that means I need to substitute 20 into the function. I will got, 1,600 minus 40 times 8, 800, which is gives you 800. So the maximum area should be 800 square feet. Okay, that's the application of a quadratic function. Okay, so that's it for these classes. I'll see you next time.